Okay, good morning, afternoon, evening, whichever. Okay, if you are my student, you can take a pen and paper and start writing. And if you are not, do note that there are certain parts of these lessons that are taught during the actual lesson itself. So do email me and contact me if you have any queries. My email is in the description. Okay, so today we're going to go through chem bonding. Chem bonding is mainly memorizing a few small sentence or paragraphs. Okay, so basically there are 2 to 3 types of questions to answer, and you're going to memorize the wordings. Okay, I've already compiled them into tables, so let's go. So the first question is why blah 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 has a higher or lower melting point than blah blah blah. Okay, so it can be melting point, it can be boiling point, and we're going to go through the wordings now. So this is a table for my students. You can start writing. So in the your first step is to first look at the name or formula, and then search it on your periodic table. Now, if it is a metal and non-metal, if it's a metal and non-metal, then it will be ionic bonds. Okay, you fall into this column, and if they are made out of only non-metals, then this column. And if there are any of these three specifically, because in your syllabus is limited to these three, then this column, okay, because of the giant molecular structure. And if they are metals, then yeah, only metal, right? A single metal molecule, like magnesium, blah blah blah. Okay, so yeah, I'm gonna unhighlight all this and start the wording. So let's say the question asks why this guy, where NaCl has a higher melting boiling point than um, CO2, then you will say NaCl has ionic bonds and giant ionic lattice structure. Large amount of energy is required to overcome strong electrostatic forces of attraction between oppositely charged ions. Okay, while CO2 has covalent bonds and giant molecular structure, less or lower amount of energy is required to overcome weak intermolecular forces of attraction. Thus, okay, then you write whatever that's queried in the question. And then you can do the same for the next 2 columns too. Okay, so for my students, please copy them down. It will help in your memorizing of all these things. Okay, and if you need, you can pause the video to continue writing. And once you're done, you can play and continue the video. Okay, the next question is basically these are required in the syllabus, and basically it's asking you to compare the bonding and structure of diamond and graphite. Blah blah blah. Why is it harder? Why is diamond harder? Why graphite can conduct electricity while diamond cannot? Okay, so we'll go through the first one. The first one is mainly about why graphite can conduct electricity while diamond cannot, and we'll okay. So why you will say okay in graphite each C and C represents a carbon. Each C atom is covalently bonded to 3 other C atoms as such, or you can say therefore, thus, whatever, you can change your connecting words. Okay, each C atom has a delocalized or mobile. You can write either, okay, okay, but not both. Okay, so valence electron to carry electric charge. Just sorry for the typo. Okay, please write electric charges. Okay, between hexagonal layers. Okay, that's in graphite. Then while in diamond, okay, uh, each C atom is covalently bonded to 4 other C atoms, hence no mobile electrons to carry electric charges. Okay, the main point is whether there are or there isn't mobile electrons. Okay, or you can write delocalized, something else the teachers prefer that. Follow their format, and this is the structure of the answer. Okay, okay, and that's for this question. Okay, you can pause the video and write it down. Okay, for my students, please write it down. Thanks. Okay, next one is on the hardness, like why diamond is harder than graphite. So you will say diamond requires large amount of energy to break. Okay, I say again, diamond requires large amount of energy. Okay, large amount of energy in diamond. Large amount of energy is required to break. Okay, break. Large amount of energy is required to break the strong covalent bonds. Okay, within strong covalent bonds within molecules, hence it's hard. Okay, then graphite it requires less amount of energy to overcome the weak intermolecular forces of attraction. Okay, between hexagonal layers, hence it's soft. Yeah. Okay, again, my students, please write the whole table, or you can write separate sentences, up to you. But just write it down. Now, if your teacher has their own specific terms or some tweak, some changes in the wordings, do follow theirs. Okay, after all, they are the ones that mark your exam papers. Other than that, that's all for chem bonding. Yeah, quite short, right? Basically, three main tables and a few more sentences.